Mercury, named after the Roman messenger god, is the closest planet to the Sun in our solar system. It is the smallest and fastest planet, with a diameter of about 4,879 kilometers, 3,032 miles. In this article, we will explore various aspects of Mercury, including its characteristics, composition, atmosphere, and interesting features. Mercury has a rocky surface, similar to Earth's moon, and is heavily cratered due to its lack of an atmosphere to protect it from impacts. It has a thin atmosphere called an exosphere, which consists mainly of atoms blasted off its surface by the solar wind. The planet's surface temperature varies greatly, ranging from extremely hot during the day, reaching up to 430 degrees Celsius, 800 degrees Fahrenheit, to extremely cold at night, dropping to around minus 180 degrees Celsius, minus 290 degrees Fahrenheit. Mercury is primarily composed of silicate rock and metal. Its core is thought to be large and molten, making up about 85% of the planet's radius. This core generates a magnetic field, although it is much weaker than Earth's magnetic field. The surface of Mercury is covered in a layer of dust and rocks, with some areas containing smooth plains and others displaying rugged terrains. Mercury's exosphere is extremely thin, consisting mainly of hydrogen, helium, oxygen, sodium, calcium, potassium, and water vapor. Due to its weak gravity, the planet is unable to retain an atmosphere like Earth, and any gases released into the exosphere quickly escape into space. One of the most prominent features on Mercury is the Caloris Basin, a large impact crater about 1,550 kilometers, 963 miles, in diameter. It is one of the largest impact basins in the solar system and is surrounded by a ring of mountains. Another notable feature is the planet's long, tall cliffs called scarps, which can extend for hundreds of kilometers. These scarps were likely formed as the planet's core cooled and contracted, causing the surface to crack and buckle. Mercury has been visited by only one spacecraft so far, NASA's Messenger, Mercury Surface, Space Environment, Geochemistry, and Ranging Mission. Messenger orbited the planet from 2011 to 2015, providing valuable data and images of Mercury's surface, composition, and magnetic field. The European Space Agency, ESA, is planning a mission called Bepi Colombo, which is set to launch in 2024 and will study Mercury in more detail, orbit and rotation. Mercury has an elliptical orbit around the Sun, taking approximately 88 Earth days to complete one orbit. However, due to its slow rotation, a day on Mercury, the time it takes for the planet to complete one full rotation, is much longer, lasting about 59 Earth days. This means that Mercury experiences very long days and nights. Lack of moons. Unlike many other planets in our solar system, Mercury does not have any moons or natural satellites. Transit of Mercury. Occasionally, Mercury passes directly between the Earth and the Sun, resulting in a transit. During a transit, Mercury can be seen as a small black dot moving across the face of the Sun. These transits are relatively rare and occur about 13 times per century. Extreme temperature variations. As mentioned earlier, Mercury experiences extreme temperature variations. The side of the planet facing the Sun can reach scorching temperatures, while the side facing away from the Sun becomes extremely cold. This stark temperature difference is due to Mercury's lack of atmosphere, which fails to distribute heat evenly. Tectonic activity. Despite its small size, Mercury exhibits evidence of tectonic activity. The planet's surface is marked by numerous faults and scarps, indicating that the planet's crust has undergone significant deformation. These tectonic features are believed to have formed as the planet's interior cooled and contracted over time. Water ice. Surprisingly, despite its proximity to the Sun, Mercury has regions near its poles that are permanently shadowed from sunlight. Scientists have discovered that these permanently shadowed craters contain water ice, which is believed to have been delivered by comets or formed through other processes. The presence of water ice on such a hot planet is a fascinating discovery. gravity and escape velocity. Due to its small size and low gravity, Mercury has a relatively low escape velocity. This means that it requires less energy for an object to escape Mercury's gravitational pull compared to other planets. As a result, Mercury has difficulty retaining an atmosphere, and any gases released into its exosphere tend to escape into space. In size and density, Mercury is the smallest planet in our solar system, with a diameter of about 4,879 kilometers, 3,032 miles. Despite its small size, it is one of the densest planets, with a density similar to that of Earth. This high density suggests that Mercury has a large metallic core relative to its size. Lack of atmosphere. Mercury has a very thin atmosphere, known as an exosphere, which contains only trace amounts of gases. The lack of a substantial atmosphere means that Mercury is bombarded directly by solar radiation and charged particles from the Sun. Retrograde rotation. Unlike most planets in our solar system, which rotate on their axes in the same direction as their orbit around the Sun, prograde rotation, Mercury has a retrograde rotation. This means that it rotates on its axis in the opposite direction of its orbit. Scientists believe that this unusual rotation may have been caused by a giant impact early in the planet's history. Magnetic field. Despite its small size, Mercury has a magnetic field, although it is much weaker than Earth's magnetic field. The origin of Mercury's magnetic field is still not fully understood, but it is believed to be generated by the planet's molten iron core. Solar wind interaction. Mercury's close proximity to the Sun exposes it to intense solar wind, which is a stream of charged particles emitted by the Sun. The solar wind interacts with Mercury's magnetic field and exosphere, creating unique phenomena such as magnetic tornadoes and a comet-like tail. The difficulty in seeing it notwithstanding, Mercury was known at least by Sumerian times, some 5,000 years ago. In classical Greece, it was called Apollo when it appeared as a morning star just before sunrise, and Hermes, the Greek equivalent of the Roman god Mercury, when it appeared as an evening star just after sunset. Hermes was the swift messenger of the gods, and the planet's name is thus likely a reference to its rapid motions relative to other objects in the sky. Even in more recent eras, many sky observers passed their entire lifetimes without ever seeing Mercury. It is reputed that Nicolaus Copernicus, whose heliocentric model of the heavens in the 16th century explained why Mercury and Venus always appear in close proximity to the Sun, expressed a deathbed regret that he had never set eyes on the planet Mercury himself. Until the last part of the 20th century, Mercury was one of the least understood planets, and even now the shortage of information about it leaves many basic questions unsettled. Indeed, the length of its day was not determined until the 1960s, and Mercury's nearness to the Sun gave scientists bound to Earth many observational hurdles, which were overcome only by the messenger, Mercury's surface, space environment, geochemistry, and ranging probe. Messenger was launched in 2004, flew past the planet twice in 2008 and once in 2009, and settled into orbit in 2011. It mapped the entire surface of Mercury before crashing into the planet in 2015. Mercury's proximity to the Sun has also been exploited to confirm predictions made by relativity theory about the way gravity affects space and time. Mercury's temperature range is the most extreme of the solar system's 4 inner terrestrial planets, but the planet's night side would be even colder if Mercury kept one face perpetually toward the Sun and the other in perpetual darkness. Until Earth-based radar observations proved otherwise in the 1960s, astronomers had long believed that to be the case, which would follow if Mercury's rotation were synchronous. That is, if its rotation period were the same as its 88-day revolution period. Telescopic observers, limited to viewing Mercury periodically under conditions dictated by Mercury's angular distance from the Sun, had been misled into concluding that they're seeing the same barely distinguishable features on Mercury's surface on each viewing occasion indicated a synchronous rotation. The radar studies revealed that the planet's 58.6-day rotation period is not only different from its orbital period, but also exactly two-thirds of it. Mercury's orbital eccentricity and the strong solar tides, deformations raised in the body of the planet by the Sun's gravitational attraction, apparently explain why the planet rotates 3 times for every 2 times that it orbits the Sun. Mercury presumably had spun faster when it was forming, but it was slowed by tidal forces. Instead of slowing to a state of synchronous rotation, as has happened to many planetary satellites, including Earth's moon, Mercury became trapped at the 58.6-day rotation rate. At this rate, the Sun tugs repeatedly, and especially strongly, on the tidally induced bulges in Mercury's crust at the hot poles. The chances of trapping the spin at the 58.6-day period were greatly enhanced by tidal friction between the solid mantle and molten core of the young planet. The first significant telescopic data about Mercury after the Mariner mission resulted in the discovery in the mid-1980s of sodium in the atmosphere. Subsequently, better Earth-based techniques enabled the variations of several of Mercury's atmospheric components to be studied from place to place and over time. Also, ongoing improvement in the power and sensitivity of ground-based radar resulted in intriguing maps of the hemisphere unseen by Mariner 10 and, in particular, the discovery of condensed material, probably water ice, in permanently shadowed craters near the poles.